Okay, good morning, Algebra 2 CP. This is period A1 and A4, and we're going to talk about some evaluating functions today. Hope you guys are ready to get started. As you can see in my little layout, I am going to have a webcam coming soon, but I have everything else pretty much set up. So if you do have any questions, please feel free to reach out. You can see my email address up on the screen, and make sure to check in during office hours if necessary. All right, let's go ahead and get rolling. We're going to talk about today a little bit of evaluating functions, which largely will be a review from Algebra 1. But I want to hit you with this topic first because there are a couple really important definitions that I want to make sure you have a good handle of, and it'll really lay the foundation for us going forward. So first of all, if I'm going to talk about evaluating functions, it's probably good to define what a function actually is. And the definition of a function is that it's a mathematical relation in which each input value, and we call those input values x, maps to exactly one corresponding output. And we refer to those output values typically as y. Okay? So that's what a function is. It's a relation in which each input maps to exactly one output. In other words, if you take a number and plug it into a function, it will always produce the same result. It's not like you could take 2, plug it into a function, and get a different answer. Those input values specifically are referred to as these words that you may have seen before, the domain and the range. We're going to talk a lot more about domain and range next class, but the domain refers to all possible input values for a particular function, and again, those are x's. And your range refers to the set of all possible output values for a particular function. All right, so just a couple quick little definitions. Again, we're going to talk a lot more about domain and range next class, but just wanted to hit you with those at the very start so we can make sure we know what we're talking about. When we evaluate functions, more than likely, you're going to see them written in function notation. In Algebra 1, you've probably used notation similar to y equals something like 2x minus 1, for example. Well, in Algebra 2, we're going to step that up a little bit, and instead of using y equals, we're now going to be doing f of x equals 2x minus 1. And notice that that is pronounced f of x. And what that means, if you're curious how the notation actually breaks down, we say that this is a function named f, which is the default name because f stands for function, in which x is the variable. Okay? So that's what it means when you say f of x. If you have a function named z where you have q as the variable, you would say it's z of q. You know, it doesn't matter what variables or letters you use. It just is typical that you would see f of x as the default. All right? One other piece of vocabulary quickly before we jump into it is that functions can be categorized based on their degree. So functions, it's a little note here, can be classified or categorized, however you want to do it, based on their degree. Now, of course, degree brings up another great vocabulary word. Degree, when we talk about it in terms of functions, is not the same as like in geometry where you say an angle has a certain number of degrees as far as its measurement. The degree of a function, more vocabulary. That's why I wanted to start out with a lot of definitions first, just to make sure we're on the same page. The degree of a function is the value of the highest exponent to which a variable is raised. I'd like to fit that on one line, but that's all right. Is raised. Okay? So I'll give you a couple examples. if I had a function like this is f of x equals x squared minus 3x plus 7, you would look at that function and you would say that this is degree 2. And the reason it's degree 2 is because the highest exponent in the function that the variable is raised to is x squared. Okay? Just another one real fast. Something like g of x equals 10x to the 4th minus x to the 5th plus 2x, right? This function, I would say, even though it doesn't come first, which it should come first if you're writing it in standard form, which is descending order, but I would say the degree of that function is 5, degree 5. Okay? So when you start with categorizing functions based on their degree, the lowest degree function that you can encounter with a polynomial function is something that's degree, oh, I didn't write it, degree 0. Okay? And a degree 0 function is what's referred to as a constant function. And it graphs to a horizontal line. Looks like this. Okay, it's a line with no slope. Example of a constant function, you could say y equals a, where a is any number. Okay, like y equals 2, y equals 5, y equals negative 6. Those all graph to horizontal lines at those specific y coordinates. Alrighty. Going up from there, you have a function that is degree 1. And degree 1 is known as a linear function. Linear function is a sloped line, either a positive slope like I drew here, or a negative slope going down like this. And an example that you might see is y equals ax plus b, which typically you'd probably see as y equals mx plus b, but you can use a instead of m, that's totally fine. So like y equals 2x plus 5 has a slope of 2 over 1 and a y-intercept of 5. Going up from there, you have a degree 2 function. We're going to talk a lot about degree 2 functions this year. These are called quadratic. And quadratic functions graph to the shape of a parabola. And a parabola kind of looks either like this, or you can have an upside down parabola, which looks like almost like an N instead of a U. And the general form for a parabola, it kind of builds right off of this, where you're going to now have ax squared, because you're degree 2, plus bx plus c. You can see the standard form sort of growing, and it's a very direct translation as you go from one degree to the next. From there, that's probably what I usually expect students know coming into Algebra 2. Some of them don't know quadratic, but usually constant and linear, it's like, oh yeah, I remember those. Going up from there, a degree 3 function is called a cubic function. And we will be doing some cubic functions this year later on, maybe in like third quarter. Cubic function almost looks like two parabolas stuck together. It's not, but notice how it has 2 of these curves as opposed to a parabola which just has 1. A line has no curves, and this has no slope at all. The general form of a cubic function looks like this. Ax to the 3rd plus bx squared plus cx plus d. Okay? If you keep going up from there, we can do degree 4. This is the last one I'll do with you. A degree 4 is called a quartic function, like a quart of milk, quartic function. And just like how a parabola has 1 curve, a cubic has 2 curves, quartic function has 3 curves. It can either be upside down or right side up, like a W or an M. And the general form of a quartic function is going to be y equals, just like you see here, ax to the 4th plus bx to the 3rd plus cx squared plus dx plus e. And you can see that eventually this is going to get really long, but that's the idea of how you sort of categorize functions based on their degree. Does that make sense to everybody? So in Algebra 2 CP, most likely you've done these in Algebra 1. Algebra 2 really delves into quadratic and a little bit of cubic as well. And I think we may even see a quartic like 1 or 2 as we get into later in the third quarter. But for the most part, we'll be living in here with linear, quadratic, and cubic. All right. Awesome. So that's a little bit of background information for you. Now let's specifically talk about how to evaluate functions. And evaluating functions is exactly what you would think. It's just plugging in values for variables and figuring out what they are. There's a couple very important things you have to keep in mind, though, when you do that. All right, so let's take a look at an example. Okay, if I had a function that was f of x equals 2x squared minus 5x plus 4, like that, and I asked you to evaluate f of 3, okay, f of 3. What that means is you need to take this value of 3 and plug it into wherever you see an x. So you'd say f of 3, well that means replace all the x's with 3's. F of 3 is equal to 2 times 3 squared minus 5 times 3 plus 4. Which order of operations? I'm going to square first. 3 squared is 9 times 2 is 18 minus 5 times 3, so minus 15 plus 4. And 18 from left to right, 18 minus 15 is 3, plus 4 is 7. So you would say that f of 3 is 7. Okay? And kind of the cool connection that we're going to talk about between function evaluation and graphs is the fact that the graph of this, if you were to actually sketch a graph, since you plugged in 3 for x and you got an answer of 7 for y, this graph will have a point at the coordinate of 3, 7. That's not really relevant right now, but that will be relevant later on. Okie doke. Question about that? Hopefully we're good. Moving on, a couple more examples and then we'll be good for the day. We got, say I have g of x is equal to 2 times the square root of x minus 1 and then minus 4 on the outside here. And I'm asking you to evaluate g of 10. What I'm going to do, exactly what it seems like, I'm going to take 10, I'm going to plug them in for all the x's, saying that g of 10 is equal to 2 times the square root of 10 minus 1 minus 4. Again, we're going to follow our order of operation. We're going to do inside the square root, so that gives me 2 times the square root of 9 minus 4. Square root of 9 is 3, so that becomes 2 times 3, which is 6. And 6 minus 4 is 2. So you'd be able to say that g of 10 is equal to 2. And likewise, the same point I made before is valid, where since you plugged in 10 for x and you got 2 for y, there would be a point on the graph at the coordinate of 10, 2, if you were to sketch a graph of whatever that happened to look like. Alrighty. Any other question on that? Hopefully we're good. Give you a minute to pause. Let's do a couple more and then you'll be good for the day. So, something like this. If I have, do one with a little couple fractions in it. H of x equals, don't freak out, 1/3 times x plus 2x squared minus 5. And I'm going to ask you to evaluate h of negative 3. Okay? Well, what that means, again, is just take negative 3 and plug it in for all the x's. Be careful about your order of operations. And make sure, notice how I'm writing this step by step. I'm not doing that, I mean, I am doing it just to show you, but I'm also doing it to demonstrate how you should solve these problems, one step at a time. H of negative 3 is 1/3 times negative 3 plus 2 times negative 3 squared minus 5. Yes, eventually you may get to the point where you start feeling comfortable skipping steps, but until you reach that point, I highly, highly, highly recommend writing out each step individually. That seems to be where mistakes happen, is when students try to skip steps, and then when they skip steps and do some mental math, that's when you run into errors. Multiply here, we have 1/3 times negative 3, that's negative 1. Here I have, notice order of operations, negative 3 squared is negative 3 times negative 3, so that's positive 9, so plus 2 times 9 minus 5. 2 times 9 is 18, so I get negative 1 plus 18 minus 5. Negative 1 plus 18 is 17. 17 minus 5 is 12. So you'd be able to say that h of negative 3 is equal to 12. And when you go ahead and graph this function, again, we're going to talk a lot more about that later. It's not really relevant now, but it is an important point to say that there is going to be a point at negative 3, 12. Alrighty. One last really important point that I want to bring up here is, in addition to doing order of operations, making sure you're distributing properly and stuff like that. Like if you have something like x times x minus 5, you remember that you can distribute that, apply the distributive property, and make that x squared minus 5x. What's even sneakier is when you put a negative out on the outside of that distribution. You get negative 2 times x plus 7, for example. The negative 2 is going to distribute here and here. Actually, even sneakier if we make this a minus 7, because notice this is going to be negative 2 times x is negative 2x. Negative 2 times negative 7 is going to be positive 14. So keep in mind how that works out. The other place where students get really tripped up, and it is important, is with squaring something if there is a negative in front. So consider this as our final example. Ready? I'll use some different letters. Let's say g of a. Okay. We're going to say it's negative a squared minus 5. Okay. And I'll ask you to evaluate g of, let's do g of 3. Notice, this is very, very tempting to do, and it's also very, very bad. Don't do this, what I'm about to write. This is bad, bad, bad. Don't do this. It's very tempting to do it, though. You would say, oh, g of 3, that's negative 3 squared minus 5. Oh, negative 3 squared is 9, minus 5 is 4, right? Seems easy, seems like it makes sense, but I don't like it. Don't like it. And the reason I don't like it is this negative on the outside here. When you have a negative on the outside, it's the equivalent of saying that this is negative 1 times a squared. Okay? And if you're plugging in 3 for a, you would, by order of operations, think of PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. You would do exponents first. You don't multiply the negative 1 first. And that confuses a lot of students. The way to actually do this is you would say, well, this is the opposite of 3 squared minus 5. So 3 squared is 9, negative 9, the opposite of which is negative 9, minus 5 comes down to negative 14. Okay? So do be very mindful of that. This is not the same necessarily as this. Okay? If you have negative 3 squared, that means to take the opposite of 3 squared, which comes out to be negative 9. If you have this, negative 3 squared, very similar, very sneaky, this is negative 3 times negative 3, which is positive 9. Okay? So that's a spot where students tend to make a lot of mistakes, so that's why I wanted to point that out to you. All right, I want to thank you for watching and for your attention and focus during this. Just a little recap. We talked about definitions to get us started with function, domain, and range. We'll talk a lot more about next class. Just some more categories of functions as to how you can classify them based on their degree. And again, the degree is the value of the highest exponent to which a variable is raised. And now actually getting into evaluating functions, it really just entails taking values for x, plugging them in, and seeing what you get. Remember to be mindful of order of operations. Remember to be mindful of if you have any fractions that you're dealing with. And remember to be mindful of distributing and squaring with a negative out in front. Do the exponent first, then takes the opposite. All right? Make sure you complete the practice problems that are attached. There's a couple of them there. And I will see you guys next class. Thank you.